There are a few moments in our careers that we won't forget. For me, running PowerShell Empire was one of those. The first time was back in 2015, 2016, when it first came out. I had a friend of mine on the red team at the electric utility company that I was working at who said, hey, we need to check out this new tool. I was working as a cybersecurity engineer, implementing detection tooling. EDR tool was the next project on the gate. And he said, we should see if the EDR tools you're evaluating can pick this stuff up. Spoiler alert, no. So what we did was he kind of fired it up, had his C2 server in the cloud running PowerShell Empire, started talking, sent me a nice infected Word document with a sweet macro in there. I, of course, like any good user, clicked it. We saw seeing some things happening on my machine. He started implementing the modules that were available. I was kind of scratching my head going, wow, you know, this is some pretty cool stuff that you can do with this. And oh, by the way, our detection tooling was just like, boop, 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 nothing, right? Just that heartbeat, just still there, but we're not seeing anything. So I realized, like, wait a minute, this is a problem. So not to mention the fact that we didn't have a good detection. I started working on figuring out what could I see. We had full packet capture, we had IDS, we had all this stuff. So let me go figure out if I can make some detection tooling things in there or look at what the EDR tool sees. Okay, now I had to call my buddy up and say, run it again, let's do it. So he did some more stuff. He had this thing going. We checked it. Still didn't detect it. Okay, I got to go back. Do it again. Go back. Do it again. Right? So I realized we need to fix this cycle, right? I, as a blue teamer, need to be able to call these things on demand so that I can better run my detection ruling, right? I can fix it, I can validate it, I can implement it. So that's where the genesis of this talk came from for me. A couple of us from where I work at Splunk have been working on this together. So, and I just like Legos, right? My kids like Legos. It's like building blocks, right? I use the analogy a lot. There's a couple different pieces of this project that we've put together from the great work of others, and so I use my own little Legos there. All right, I work for Splunk. Lawyers made me put this in there. Basically says if I talk about anything in the future, you should disregard it. I won't talk about anything in the future, except I just did. All right, so what's our agenda for today? Well, we're going to start with why, mostly because Simon Sinek says we should. We're going to talk about how. Yeah, I mean, I get it. The jokes are going to keep on coming, but they're just not going to be that good. What does this look like, right? We're going to actually simulate it. And then, when can you get started? I got some stuff to help you get going right off the bat. All right, so we're going to start with why. I promise this won't get too philosophical. First, a note. Does simulate equivalent to emulate? There is some talk about these terminologies out there. And for the purposes of this talk, I don't care. So if you want to talk about simulate versus emulate, which I won't name any names, but I know some of you out there like this discussion, we can talk about it later. For right now, I'm going to use those terms interchangeably. We're just doing stuff that the adversary would do. All right, so we have the loot on the right. We have the robbers on the left. They always try to get to the loot on the right. What do? We're the cops. We put it in the middle. We put our technical controls, our policy controls, our gate guards, our CCTV. Wait, what's happening? Hold on. What are they doing? They're getting around it. They're making it to the loot. It's like the Pink Panther, right? The guy that's trying to steal the diamond, and he's in the museum, and all the laser beams, and he like contorts his body in all different ways trying to get into it. That's what they do. So, that's right. So what do? We need to focus on what they're actually doing, not necessarily checkboxing all our little controls and the stuff that we feel good about, but let's actually sit down and say, what is the adversary doing? How do we automate some of this stuff so that we can make sure that we're detecting it and then, actually make our rules better, right? All right, a couple of you out there, maybe, if anybody's saying, well, are you saying we can automate pen testing? No, I'm not saying that. There's advantages to both, right? You're going to be able to get a real behavior of a human on the other end a lot more easily with a real red team or pen test. But when automation, we can make it lower cost, right? We can make it easier to replicate. We can use it to do the thing that the red team did over and over again so that we make sure we can detect it. At the end of the day, why not both? All right, so again, to sum it up, we want to make sure that our controls work. We want to make sure that nothing's changed. One of my favorite stories to tell about this particular one is that when we had our full packet capture collecting gigabytes a day, and we didn't have a whole lot of good monitoring in place to make sure that things were working right. One day we looked at it and we realized, wait a minute, we barely got any data today. I can't find something that I'm looking for. I know it should be there. We look back, for the last 3 days, we've only gotten like 100 megabytes a day. This is bad. Called up our friends, the network team, and they said, oh yeah, we just changed the internet routing structure, put some new hardware in, no big deal. We're like, yeah, you just rerouted past our taps, so we're not seeing anything. That's cool. All right. You want to make sure that if there's stuff that's common out there, right, we're getting a better taxonomy and library of these techniques. We want to make sure that we see those. Then we're talking about if we think we see something, but we really don't, that's a blind spot. And then finally, we got to confirm what the vendors are telling us. I am a vendor, I guess, so got to confirm what I'm telling you. All right, what does this look like? Or I say, how can we do this, right? Hold on, I'm getting ahead of myself. Yep, how can we do this? That's what we're talking about next. All right, so the rest of the talk, I'm going to talk about MITRE ATT&CK. All right, good. No, I mean, the bottom line is everybody knows what it is. It's so hot right now. Like, every talk has mentioned MITRE ATT&CK at least once, and you kind of have to, right? It's kind of one of those nods. It's about to be the next cyber, right? So without talking about it too much, the bottom line is you don't treat it like a checklist. You don't treat it like a bingo card. You're not trying to make sure you got your lines across or diagonal, right? It's what is important to you, and you have to figure out what's important to you. It's just a taxonomy that helps us all speak the same language, right? So when we get to a specific technique, like T1060, for example, we're going to get the whole write-up that MITRE provides, a lot of specific references to specific threat actors, and we can cross-reference that stuff, right? So great work, great compilation, but you got to know what it is and use it for what it is. One of the other pieces that they gave with this was the MITRE ATT&CK Navigator. And this is important because this was the project written in JavaScript that's open source. We basically put this into a Splunk wrap. A Splunk app. We put a wrapper around it and then said, hey, you can use this right in the Splunk interface. This gives a couple of advantages and extensibility. It has a lot of graphic features that you can overlay information onto it, so it's very helpful. All right, next we're going to look at Atomic Red Team, brought to us by the great folks at Red Canary, specifically and especially Mike Haig and others there. This is a great project that, like MITRE ATT&CK, it goes into the details. It maps to MITRE ATT&CK. It talks about the different techniques, and then it will actually give you a specific command in a YAML file that you can run to do this technique in your environment, right? So right here in PowerShell, I would run these particular statements to actually simulate this technique in my environment, right? The fact that they've tabulated all this, compiled it, put it into YAML format so that you can automate it, makes projects like what I'm demonstrating today possible, right? So huge thanks to Red Canary and all the community members who have contributed to that. One other tool that I'll be mentioning is called Scythe. This is basically a way to kind of, instead of using discrete atomic tests, you can kind of piece those together into a longer chain and run it from a binary. So this is just one thing that I've leveraged. It's a C2 framework that was talked about yesterday in the C2 Matrix talk, but it's basically like a way to do more advanced things and not just single discrete tests. All right, so the Adversary Simulation Project, me and my two buddies, we moonlight for a band called Wild Stallions, if you've ever heard of them. But no, we kind of came together and put together this idea and what we wanted to try to build. Dave and Kyle are at Splunk with me. Kyle built a lot of the JavaScript parts of it, the Attack Navigator app into the Splunk app, so a lot of great work in how we did this. One thing to note, we use Splunk, but you don't have to, right? The idea is that we're just using this as the canvas upon which we paint our narrative and our story of what I'm trying to get across when we're simulating the adversary for better detection. All right, so let's talk about a couple key components. I'm going to get to a diagram right on the next slide, but I want to outline a couple things. These are the pieces that we put together, right? So building on the shoulders of giants that we just come through, these are the pieces that we added. So the Attack Navigator app in the Splunk Attack Sim app, the Simulation Runner dashboard, this is what actually kicks the test over to Phantom to run it in the environment. Then Phantom is the automation engine that actually talks to the Windows endpoint or pulls the relevant content from Atomic Red Team. Kind of orchestrates this whole process. Windows Remote Management is the actual mechanism by which we talk to an endpoint and run a PowerShell or command.exe command. Pretty common service. Microsoft puts it out. It's by default on all current versions of Windows. So it's a pretty great way to kind of have some scaffolding and get information there. A playbook within Phantom is what orchestrates the whole process. I'll be stepping through that and kind of how that works. And then the Windows target system. Obviously, if you have no detection mechanism on your endpoint, you're not going to get anything back. So you want to make sure that you have, in our case, we use Sysmon, other EDR tools, great. We're using WinRM for the actual connection to it, and then we're using Splunk Universal Forwarder to get that data back into Splunk, obviously. But whatever detection mechanism you have, that would be where you implement it. All right. So what we added is in the orange boxes here. This is the kind of overarching diagram of how it all works, right? A lot of moving parts here. But the idea is that from the Attack Sim app in Splunk, a blue team defender would be able to initiate the attack, right? Initiate the test, and then it would kick over to Phantom. Phantom would pull the appropriate command line execution parameters. They would then run the playbook, send it to the Windows system. That would then be logging to Splunk, and right there in that same dashboard where they initiated it, they will be able to see what sort of events are being populated based on what they just did. At that point, you can use analytics, either Splunk provided, third-party provided. My favorite source is Olaf Hartong's threat hunting app. He's done a lot of work in mapping a lot of detection searches in Splunk to specific MITRE attack techniques. So great source of content there. All right, so looking at the Attack Navigator app in a little more details, I mentioned briefly you can overlay layers on this, right, which was an inherent feature of the Attack Navigator. It's really useful for kind of pinpointing which things are of interest to you, which techniques a certain adversary may run, and also what your detection status is on those, right? Now, we want to stay away from green and red because that's a little bit too binary. So we've kind of gone to the darker shades of blue for the more confidence in your detection, right? The other thing that we did add was a little bit auto refresh feature in this interface, so that you could actually, have these tests running in the background, and then it would update based on whether it detected according to your search. This also is helpful for if you're going to track your progress, right? A lot of people want to say, hey, our goal is to be really high confidence in detecting, these 10 techniques that this particular actor set uses against our industry, right? So those are the 10 techniques of interest. Day one, where are we at? We only detect 2 out of 10, and that not so good. Okay, so how are we going to make progress, and then how are we going to track that progress? All right, Simulation Runner Dashboard app. This is basically where we actually fill in a couple parameters for the test that we want to run, and then we send it over, right? This is also where the events will populate once we're seeing what's happening on that Windows endpoint. Again, the bottom line of this is that the blue teamer is the one that can initiate, can let it run, and then can observe exactly what's happening and validate the specific detection search that you want to validate. All right, let's step through the playbook. I'm going to try to move fast through this. I know you can't read this, but just, this is basically an outline of what we're doing. What I want to talk about is the different block sets of what I'm doing so that you understand what's happening. First thing is I'm posting an event to indicate the start of the test, right? This allows me to bracket the beginning and the end so that I can narrow down my time for what I'm searching for. I check the OS. There would be mechanisms in here, and it should be pretty straightforward. I just haven't done it to make it work on Mac and Linux. Right now, we're only supporting Windows. Once we get into Windows, we'll actually go direct and make an event in the Windows event log for what we're doing. Then we get up here and we check, do we want to run an atomic test, or are we running a more advanced campaign with Scythe? If we're running an advanced campaign with Scythe, we'll actually go through, kick that off, download that binary to the Windows host, and then it will actually run that series of tests that we're doing. If we're an atomic red team test, we'll actually go out, format the command appropriately, run it in PowerShell or command.exe as necessary. Finally, we check for some execution error. If we have any of those, post it back to Splunk so we can see it. And then we'll post our end events that give us the closing bracket for what we're trying to see here, right? So all that's happening in the background. You don't have to do any of that, right? That's the point of automating this and kind of having it. It really just runs in Python code. This is just a visual representation of it. All right, so this is a brief philosophical note. I know we're here in the ops track, but every now and then I like to wax philosophical. When we create new detections for these types of things, especially with Atomic Red Team, please don't spawn an investigation or an alert that goes to an analyst off a detection off of every single one of these, right? The idea is we're trying to detect discrete things that are of interest and then piece those things together at a later stage. So what I'm advocating is instead of going straight from detection to analyst investigation, say detect 4 different things, 4 different techniques that happen on the same asset. Now that should spawn an investigation. If I just have 3, okay, maybe that's okay. Maybe that's my threshold. But you can start to get that gauge of risk, right, of where you're starting to see more of these type activities that could be benign, could be malicious, but strewn together, they actually become more malicious. All right, so now, what does it look like? Dramatic water swing. Here we go. We're going to do it live, because that's what Bill O'Reilly says. Woo! High-risk operation here, ladies and gentlemen. All right, so first I have to make sure that I'm connected to my Splunk instance, which I am. I'm running Wi-Fi off my phone, so I apologize if it's slow. But you see here in the Splunk interface, which I'm going to zoom in a couple places, we have the full-blown attack navigator, right? Which you may or may not have seen before, but we have all our different techniques. And when I hover over it, I get metadata, just like you would expect. If I right-click on one of these guys, I can go down and get a menu. A couple things here. View Executor. This we've actually linked out to the Red Canary page, so I'll just demonstrate that. It says here's the Red Canary page for what this is actually going to do. And if I look at this a little bit closer, scroll down, it's going to run in command prompt, and it's going to run net account / domain. Okay, cool. So I can double check what that's actually going to do for this particular technique, 1201. Back to my board, right click, say run test. That's what that says, I promise. This will actually open the simulation runner dashboard where I can fill in the appropriate information. So zooming in, I have the technique name that's been populated from my previous attack navigator, the technique ID, some things that are by default, a couple things that I need to select, the Phantom server I'm going to run this on, the asset, and then I can pick from either pre-built content that Splunk provides or third-party content if I want to add a additional search. So this would look through all my saved searches and then other content as well. I'm going to use one of those from Olaf Hartong's threat hunting app that anybody can download. T1201, like I said, he maps to the MITRE attack technique, so really easy to kind of go through and pick out what a starting search is. It may not work for you, but it's a great place to start. All right, so once I select all these things, this kicks off. Then I start to see, this is my posted event that my playbook did when I started the test, right? So started red team test on machine with IP address as follows. Now, what is happening in the background is that Phantom playbook is running it, it's selecting the test, it's then kicking it off on the Windows system, and in just a minute, we should see the finished event if I refresh my panel here. All right. So now here's an example error post that would happen if something doesn't work. So this test actually ran two commands. One was net accounts, one was net account / domain. The net account / domain doesn't work because this particular Windows machine was not connected to a domain at the time. All right, then we got a finished red team test at the end here. Now you'll notice we have a time here and a time back at the start. This is important because this is what brackets our searches in the follow-on panels, right? So as we go down, we can see more of these things actually populating. Now, I have the next panel is the detection search that you selected from the drop-downs above. I can look at what it's providing. So I can see the full search here, which is what it will show, and then I can see if I get any hits, right? So if I get hits on this detection search, then I'm probably doing pretty good, right? So I can see these were process create events. I can see here's one from net1.exe, net.exe, et cetera. I get some of these things populating in, right? So that's what I want to see. So if that's the case, then I can go ahead right up here, pick one of my handy-dandy radio buttons, and that goes back and updates my attack navigator visually. So let's see, just so I can show that. We have the attack navigator here. It's a nice shade of dark blue. If I go to needs data, this will turn red. Ooh, I love colors. Colors are so nice. Maybe I should be in management. I don't know. But so then I go up to detection for multiple sub-techniques, right? That would turn it back to a nice shade of mediocre blue, right? Boom. So the idea is that you have these things going, you validate that it works. If it doesn't work, what would I do? Okay, I could open this search in a new Splunk panel, right? And say, okay, now I need to tweak it, make it work to detect what I want, reload it, have it saved, pick it from my drop-down, and then I'm off and running, right? So if I don't have anything, there's other panels that are built on this as well. Let me zoom in again. So if I've got sysmon registry events, decoded PowerShell commands, so I could see exactly what type of things are being run in PowerShell during that time. Command.exe commands, these are the ones that I would expect to see based on the technique that I ran. Net accounts/domain, right? There's also file create events from sysmon, and then a panel that has all the sysmon events that happened, right? So a lot of useful information there. The idea is that this is my hub that I'm doing this from. Is that I don't have to go back over, right? Here's that Phantom playbook that's running in the background, although you can't see that again. And here's Phantom. You don't need to know all that stuff, right? I'm doing that directly from here. It's kicking it off. It's all happening in the background, and then it's populating back into the tool that I'm using for detection, right? And where I'm going to start doing this. So that concludes my demo. Thank you. Thank you. All right, so a couple more slides. We're doing okay on time. All right, good. I talked fast. When I rehearsed this, I went long, but it's the adrenaline. It always is. All right, so when can I get started? Now, that's in your voice, right? You're asking that question. When can I get started with this? Because that's the next thing that I want to do. Aha! I have a GitHub repository. What would you know? There's actually a video on there of me doing that demo if you want to watch it again over and over. Put yourself to sleep. I don't know. Whatever. There's an install guide on there that actually says, okay, you have Splunk, you have Phantom, you have the community edition, the free edition. Install these things and make it work. It's easy to do. Then, my favorite, I forked Chris Long's detection lab. Great thanks to Chris Long. Amazing work. He has an AWS option with Terraform. I forked that and added in a Phantom box that you can spin up using the AMI that's out there. You can get it up and going. If you're already on AWS Terraform, it's about 30 minutes. If you haven't ever done it, that's why I caveat and say it might take you a little bit longer to get familiar with that stuff. But the cool thing is that it already has Splunk and Phantom talking. It already has a Windows box. It already has these things set up so that you can run some of these tests straight out the gate. So it's your turn, right? I've got a couple people that have helped me out beta testing some of this stuff, but I would love more feedback. So feel free to go out there, check it out, take a look at it, try it out, say, hey, I got stuck on this, or this thing's not working. It's in active development, so disclaimer, right? It's constantly being updated. But there's a lot of things that I want to do in the future, too, me and the other guys that are working on this. So we would appreciate any input, any thoughts on that, and I hope you get some value out of it. Thanks to the guys who I listed on the slide here, Olaf Hartong, Chris Long, MiterTAC, Red Canary, great work. The folks that did the beta testing, Andrew, Johnny, and David, really appreciate the time that they put into that to help make this work. So we've covered all the things. Remember, be excellent to each other and party on.
So I understand you're doing it in Splunk because that's what you do. But is it documented in a way that we can recreate this in something else?
So there is the yes. I mean, the short answer is yes. It would take some work to figure out, okay, what are you going to do in Elastic? But Phantom has enough APIs that you can push to it and have it run. The other tools, like obviously Atomic Red Team is open source. So a lot of this stuff is out there. It's pretty straightforward, but it would take a significant, it's non-trivial effort to try to do it in something else.
Is it hosted in GitHub or anything?
Yeah, so all the pieces that I listed back on the slide that we added, all this stuff, where did I put that? So on this slide right here, yeah. All the stuff in orange, yes. All the stuff in orange is on our GitHub, right? So this is the things that we added, pieces that go into this larger ecosystem. And that GitHub site was what I put towards the end of the deck. And I'll go back to that slide here shortly. Rapture. Yep. So, I mean, the idea is if you want to get started with it, right, use this option, the AWS Terraform, because it includes the Linux box that already has Splunk on it with the trial license. It includes a Windows box that already has, the trial license. It includes Phantom with the Community Edition license. It includes all that type of stuff, right? So it's all there. Yep.
All right. Obviously, this was focused in regards to having Windows logs. So do you have anything for non-Windows logs related data? For example, you mentioned the registry and auto runs, but yet the only way to get that logged is by enabling those logs, which you should mention the Windows logging cheat sheets, to get people to a level that will record all this. But what do you do for non-Windows logs related data?
Yeah, it's a great point. So we're mostly using Sysmon, right? Which Sysmon does capture registry event changes, right? So we're using Sysmon. I think it's type 11 and 12 or 12 and 13. But one of those event codes will actually show up from Sysmon stuff for registry. If you're not doing any sort of Windows logging, it's going to be difficult, right? I mean, we're talking about endpoint type stuff here, the type of techniques that are running on an endpoint, and then the things that you're going to be collecting. So I would recommend Sysmon with an appropriate configuration, and or, to your point, the Windows logging cheat sheets of like which events IDs do you need to make sure to enable.
Another point is Sysmon's generated data will overwhelm most Splunk licenses, so beware of that. It's incredibly noisy.
So if you tune it right,
configs become real favorable there. But there's also another project that Olaf and I worked on called Arthur, Attack Remote Threat Hunting Incident Response, which is a Windows remoting packaging solution, a fork of Conza, which will allow you to execute binaries on remote systems, pull that data back to your central system, unlike Conza did. That could augment some of this WinRM stuff and allow you to run whatever tool sets for non-log related data. So just another free open source that's at GitHub, Malware Archaeology, you can find it there.
Thanks.
Cool, thank you, that's awesome. Other questions?
I know I'm separating you and lunch, so...
No, you're not the last one. It's
oh,
okay.
There's another one. Just kidding. Everybody wants to talk about lunch because we're all like, man, it's time to eat. Hey.
So this is really cool. I was curious, since this is Windows only right now, what I guess some of the differences and the major hurdles are to having like Linux and Mac capabilities for this.
Yeah, so it's really not that much. It's really just because I'm a little lazy. So there's an SSH construct that we would connect to the Windows the Linux or Mac host. You would have to have SSH open, right, to listening, which is usually not a problem on a Linux server, but Mac maybe not always there, right? But you can do it if you have it turned on. Atomic Red Team has a lot of good tests for Mac and Linux, so it's out there. Like I said, it's just a matter of building those additional logic paths in how this all functions, right? So if I could just get off my butt, it'd be fine.
Other questions?
Or you could help with that too. Welcome. Yay. Always looking for involvement.
Alrighty. Thank you very much.
Thank you.